In this video, we're going to look at examples of compound absolute value inequalities. So first example, absolute value of 2x minus 3 lies between 0 and 1. It's important to go ahead and draw this and think about where can your number lie. So absolute value of this number, whatever 2x minus 3 number is, this absolute value of this number lies between 0 to 1. So that number can be here, or that number can also lie between -1 to 0. So that number 2x minus 3 can be between -1 to 0, or the number 2x minus 3 can be between 0 to 1. And remember, there's no equal signs here on any of the inequality sides. So let's go ahead and solve these two, and wherever we have the overlap, and that would be our solution. So solve them two separately. Add 3, divide everything by a 2. So x can lie between 1 and 3 halves, or the other option was the x can be between 0 and 1. 2x minus 3 is between 0 and 1. So when we solve that side, we get divide everything by 2, 3 halves to divide, that would be x. 4 divided by 2 is 2. So my number x can lie between 1 and 3 halves, or it can be between 3 halves to 2. And that's going to be the solution to this inequality. Any values picked between 1 to 3 halves or picked between 3 halves to 2 will make the original inequality true, and you can check it for yourself. Here's another example. Absolute value of a number lies between 2 and 8. So that number can be either here on the number line, or it can be here on the number line. So I'm going to write it as two inequalities. That number 3x plus 1 over 2 can be between -8 and -2, or it can lie between 2 and 8. So let's go ahead and solve them separately. To isolate the x, I have to multiply with the 2, which is -16. 3x plus 1 less than -4. -1. -4 minus 1 is -5. And I get -7/3 less than x less than -5/3. So that's one side of the solution. And let's see what we get from the other inequality. Multiply everything with the 2. Now subtract 1. So we get 1 less than x less than 5. So x can lie, our solution is going to be x can lie between -17/3 to -5/3, or it can lie between 1 to 5. And there's no equal sign again. See another example. Absolute value of x minus 5 lies between 0 to 3. Now keep in mind, this problem is slightly different because you have an equal sign here and you don't have an equal sign here. So that means it was 3 here. This number can lie in here or in this zone, but it cannot lie at 0. It cannot equal 0. That's one of the restricted numbers. So when I separate into two inequalities, I can say the number x minus 5 lies between -3 and 0. It can equal to -3, but not equal to 0. Or the number x minus 5 lies between 0 and 3, and it can equal to 3. Keep in mind the signs. Be careful about if there's an equal sign, carry it with the next step, with it in the next step. So let's solve for x individually from both. When I add 5 everywhere, this is going to give me x lies between 2 to 5. Or when I add 5 everywhere in the next inequality, I get, there's no equal sign here. 5 less than x less than equals 8. So looks like the solution is between 2 to 8, but not including the 5. So I'm going to say 2 to 5, including the 2 with parentheses around 5 and including the 8. So solution in interval notation would be bracket around 2, to 5, union parentheses 5 to 8, and 8 bracket around the 8. Let's see one more example. Here, it's a compound inequality with absolute value in it. First step is to get the absolute value alone. So I'm going to add 4 to each side. Divide everything with the 2. So absolute value of this number lies between 5 to 8. So the number can be here on the number line, or the number can also lie between -8 and -5. So I'm going to split it into two inequalities. The number x minus 3 can lie between -8 and -5, or the number can lie between 5 and 8. So solve them individually, add 3 everywhere, -5 less than x less than -5 plus 3 is -2. And when I add 3 here, this is going to be 8, x less than 11. So my solution is going to be either that number, x can lie between, x can be between -2 and -5 here, or x can be between 8 and 11 here. Those values will make my inequality true. So between -5 and -2, no brackets, all parentheses because there's no equal sign, and that would be the solution to this inequality. And we can also represent it on the number line if needed. So my solution will be from 8 to 11, and we can make it bold, or between -2 to -5. Right, another example. Now, what if we have absolute value on both sides in a compound inequality? Remember a property of numbers, the absolute value of a is equal to square root of a square. So if absolute value of a is less than absolute value of b, that means square root of a square is less than square root of b square, and we can use that property here to solve these inequalities. So here's my first example. Absolute value of x plus 1 is less than absolute value of x plus 2. Okay, so that means x plus 1 square root is less than x plus 2 squared square root. Now if I go ahead and square both sides, I would be able to get rid of square roots. So x plus 1 squared is less than x plus 2 squared. That's x squared plus 2x plus 1 is less than x squared plus 4x plus 4. Now I do have x squared on both sides that I can get rid of. Rest, I'm just going to try to isolate the variable x. So subtract 2x from both sides, and that's going to leave me with 2x here, -3 halves less than x. We can say x greater than -3 halves. So my solution in this case would be everything bigger than -3 halves. Everything to the right of -3 halves, not including -3 halves, will be my solution. So in this video, we saw some compound absolute value inequality examples.